Hi everyone, my name is Mrs. Lewis. I am going to go over today just the lesson for your remote days. So the days that you are at home, not on a Zoom call with me, which is always Fridays, you will be doing your remote days lessons. So right now, at this point in the year, it's just going to be one lesson that you can complete over the course of the 2 days that you're remote at home. So the remote days, this is a new vocab word I'm going to use, is the 2 days a week where you will be working from home. The assignments will be posted on Google Classroom, hopefully Monday, 8 a.m. every week. And it will usually be one big lesson with multiple parts. This week it's not a big lesson, so I ask that you watch the entire video and follow along and do the small assignments attached. Today, I'm asking that all your work is written out in your science binder and not typed on your computer. So these written notes and written deliverables, like pieces of classwork, will be turned in as an image on Google Classroom. So please take notes on new words that you hear during this lecture and new ideas and things like that. Please don't take notes on every single word that I say. I just want to see that you're kind of paying attention as I go along this slideshow. So if you have to pause and take notes for a long time, then that's probably too many notes. So please just go along with it, write down the things that stick out to you as new, and then that'll be plenty of notes. So I'm going to go over this in class, but supplies that you're going to need for this class are a binder for science only. I cannot express how easy it is to lose all your science work if it just goes in a regular random binder that you put everything in. So I would prefer you have a science only binder with 20 to 30 sheets of lined paper and with binder tabs, which I will eventually tell you about what to title them. An alternative is that you could have a notebook and a folder for science only. However, I would prefer you have a binder so we can 3-hole punch everything and put it in the binder in order. Okay, blue or black pen, pencil, and eraser, and completed homework every week when it's due. These are the tabs that I want in your binder. Notes, classwork, homework / labs, and quizzes / tests. So whenever you get any of that stuff back, or whenever you write notes, or whenever you do classwork, which is what we're going to do today, I would really like those organized in those different tabs, which I'm going to talk about in class as well. So today we're going to have an agenda during this lesson. I'm going to tell you what a SWIBOT is. We're going to talk about Bloom's verbs, Q-chart, NGSS practices, and the engineering design process. So this is a lot of new words that you probably have never heard before. So I'm just going to go over them. You don't have to take super diligent notes. I'm just going to go over these. You'll see them over and over again. I'll keep repeating these things, but today's just a quick overview of that. So the first thing, SWIBOT stands for students will be able to, okay? So anytime you see SWIBOT, that's what it stands for. Students will be able to. So today's SWIBOT, so this is an objective, something we want to hit today, is students will be able to apply Bloom's verbs, which I just talked about, that we're going to learn today, and Q-chart to earth and space science topics. So we're going to be able to apply these new words to these topics that we're going to learn in this class. Okay, that's our goal for today. That's what the SWIBOT is. It's a goal. So we're going to start with bell work, which when you're in the classroom, it's going to be 5 minutes at the beginning of class to answer a question. So please take 5 minutes in your notebook. Please make sure to write the date, write out the entire SWIBOT, which I rewrote right here for you, the question, and then your full answer, okay? So in your notebook, you need to write today's date, and then you need to write out SWIBOT, apply Bloom's verbs and Q-chart to earth and space science topics. And then you need to write out this question, and then please answer it, okay? Give yourself about 5 minutes to do that. It doesn't need to be perfect. It just needs to be kind of your thoughts. So look at all the units down below. These are all the units we're going to learn this semester. Which ones interest you the most, or just pick one and tell me why it interests you the most, okay? So look at all the topics down there. write 3 sentences, pause this video, write those in your bell work section of your notebook, just make a bell work section and write this answer down, 3 sentences, and then play the video again. All right, so then I'm also always going to start class with prayer. So even when we do remote days, I will also try to have a prayer prepared for you. Okay, so we're going to do this back to school prayer, which we're going to do in class 2 this week. In the name of the Father, and of the Son, and of the Holy Spirit. Dear Lord, use my eyes to see new friends, open my ears to hear my teacher, open my mind to learn new things. Let my heart remember you are near when I'm afraid. Help me to love others like you do. I want to shine your light so bright in my school. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Okay, so the first thing on the agenda was the bell work, I think, and this is the next thing on the agenda. So I'm just going to tell you about what Bloom's verbs are. So you'll be seeing a lot of these verbs throughout Earth and Space Science, especially in our objectives, in our SWEBOT. So students will be able to, remember, understand, apply, analyze, evaluate, create. So if you think about it, from the bottom to the top, remember, up to create, it gets more difficult. It's a more difficult verb. So it's pretty easy to remember something. So if you go look over here to the right, it also has other examples that are on the same level of difficulty as remembering something. So defining something, duplicating something, which is copying something, right? Listing something, memorizing something, repeating something, stating something. Those are all things that are take a little bit of time to do, but they're not super difficult. Most people can remember things. It's recalling basic facts and concepts. And then as you go up the ladder, it gets more difficult and more difficult until you get to create, which is actually one of the higher levels of thinking. So if you personally as a student have to design something or construct something yourself, that actually takes a lot of thought and a lot of build-up. So that's higher up in this Bloom's pyramid. Okay, so then these verbs in between kind of get a little bit harder as you go up to the top. And they each have more verbs over here that we can use on the same level. Okay, so when we have SWEBOTs, which will come up a lot in this class, you'll see that we need to cover all of these bases. So we will have some under the remember column. We'll have some where we're just defining things or we're just memorizing things. And we'll have some all the way up here at creating things, okay? We will construct some small projects and things like that. And we'll have some in the middle too. We'll have to apply our knowledge to real world situations and stuff. So everything in between. This whole triangle needs to be learned by students, but it goes from in difficulty level of learning from bottom to top. Okay, that's what the Bloom's verbs are. The next thing that I want to share with you is this cue chart, which is kind of just a helpful way to make a question. So sometimes if I just ask you, so tell me, make up a question. Most people will say like, what is blank? Like, what is space? Okay, but a cue chart helps you to make more, to be more intentional with your question asking. So if you really just want to know what is space or what are stars or what is the moon or who can study space or things like that, if you want to know basic facts like that, you're going to be in this factual column of questions, okay? Sometimes it's harder to come up with more than just a factual question, okay? But if you have anything that starts with what, where, when, or who, and then is the verb is, did, or can, it falls in this factual column, right? Like, what is space? That's a factual, it falls right here. Or who can study space? That's factual, okay? When did the moon get discovered? That's a fact, right? That's a date. But sometimes they get a little bit more difficult than that, like, where would you find stars? That's predictive. That's actually a little bit harder because if you think about where would you find stars, you have to think about what makes it a star capable of being there, right? All these background things about the environment. Okay, that's a predictive thing. You have to predict something about it. Um, who will go to the moon next or something? That's not a fact. That's something you have to kind of think a little bit harder about. Analytical too. You can also come up with some analytical questions. Why does, the sun look yellow to us, right? That's not, there's a lot to that. That's kind of analyzing the sun. So that's an analytical thing. So anything with a why or how and is, did, or can, you put in the analytical section, okay? And then there's an application and synthesis section of questions, which are difficult. Some of the most difficult to ask, some of the most difficult questions to ask, and some of the most difficult ones to answer too. So, how, anything that's how would or how will, okay, so if you start like that, it falls in this green category. So I'm going to ask you later to make a question in each of these cue chart sections. So if you don't understand that, please rewatch this part of the video. So one thing I just want to do is kind of compare these. They're not perfectly comparable because the colors don't match up exactly. But if you think about what I said earlier about the bottom of this pyramid, the remember and understand section, those are a little bit more low level thinking, like just kind of straight facts, just kind of describing things, just kind of defining things. So those actually fall in the same category as factual questions, right? So what is the moon? Okay, that would fall in the same category as remembering what the moon is or defining what the moon is, right? So these lower verbs on the Bloom's pyramid actually fall in this factual category, okay? Applying to real life falls in this application section, okay? Analyzing falls in the analytical section. Analyzing falls in the analytical section. So if you are saying a question with why or how, is, did, or can in the analytical section, you're asking a question that makes somebody think a lot because it's up here on the Bloom's verbs triangle, okay? And then remember, the colors don't match, so don't be too confused by that. So they all have a spot that they kind of go in on the cue chart. So you can ask hard questions with the cue chart, and you can answer hard questions using the Bloom's verbs, okay? So they kind of go hand in hand. So this is going to be your first classwork. You're going to turn this in later, so you need to write this on a piece of paper. Please look at the Earth and space topics again, just like in the bell work. These are the Earth and space topics that we're going to go over the whole year. Earth's atmosphere, the solar system, Earth and space, the universe, sun and moon, the rock cycle, weathering and erosion, and physical features of the Earth. So look at all those Earth and space topics. Take a second to kind of understand what each of those are. And then the classwork part that you need to write down is you need to write one factual, one predictive, one analytical, and one application/synthesis question. So you need to write 4 total questions that you would like answered this year. The 4 questions must be related to any of the topics above. Okay, so I'm going to give you an example question that you cannot use on your classwork that you're turning in. So this first, so I'm going to look at one of these units, and I really like this rock cycle unit. Okay, I really want to learn a little bit more about rocks, so I'm excited to ask a question about the rock cycle. So I'm going to do my factual question on the rock cycle. Okay, so I'm going to do my factual question, which needs to fall in this category. So I'm going to do, what is the difference between a rock and a mineral? Okay, that's my question. That's my factual question. Then I can pick a new topic and make a predictive question, something that falls in this predictive category. So it needs to be a what, where, when, or who, and a would, will, or might. Okay, so make a predictive question about another unit, or it can be the same unit, it doesn't matter, but you need 4 different types of questions. So please pause the video, work on this for about 5 to 10 minutes, write out your questions handwritten, and then later I'll ask you to upload them, but you don't need to do it yet. Okay, so pause the video and go ahead. All right, the next thing I'm going to talk about here is the NGSS practices. That's New Generation Science Standards. So these are just standards for science and engineering. I know I'm giving you a lot of new vocab words, but these are just things that we are going to do and use this year. So I'm just introducing them to you. So please don't write way too many notes. Don't get overwhelmed by these vocab words. I'm just trying to explain it to you, and then I'll keep repeating it throughout the year, okay? So these are some science and engineering practices. Asking questions or defining problems, okay? So in science, you ask a question that you don't understand the answer to, and for engineering, sometimes you say, there's this problem I need to fix, okay? A lot of times, develop and using models is the next thing that you want to do. So you want to make a model that kind of represents your issue. Planning and carrying out investigations. So you guys did this in chemistry. You investigate something by, doing a lab. Analyze and interpret the data you get from a lab. That's really important in science. Use math and computational thinking to help you get to your answers. Construct explanations for science. So why did I get these answers that I got? Or designing solutions for engineering. So here is a solution based on all this information that I gathered. Okay, here's an answer to the problem. Engaging in argument from evidence. So now that you are certain based on your own evidence of a certain answer, you can go argue that and defend that, okay? That's what a lot of people do for their PhD. They find new evidence for something and they go defend that and they get a PhD. Okay, obtaining, evaluating, and communicating information. So whatever you learn, you have to be able to communicate it to somebody else, or nobody's ever going to learn these new things from you. They might have to go figure it out themselves, which the point of what you're doing is to learn something for yourself or learn something new, solve a problem, and go share it with somebody else to make the world better. So that is a good final step in these NGSS practices. Okay, so I just wanted to walk through those with you. Those are things that you do in science all the time, even though you maybe don't notice it all the time. And then one more graph, I know I'm giving you a lot of diagrams, is the engineering design process. So this looks very similar to those science standards I just said. This is just what engineers do to solve a problem. Okay, so it looks very similar to what we just talked about, but I'm just going to go over it real quick. You ask a question. We're starting at the top. You ask a question. You identify an issue. Okay. You research the problem. Do some research. Do some reading. What have other people figured out about it? Okay. You imagine a possible solution or an answer. You plan. A lot of engineers use blueprints, diagrams, sketches of models. Okay, you create a prototype. You create the first version of the model, usually smaller than normal, than it should be. You test your prototype. Does it work? Is it a good idea? Does it actually do something new? You improve it as needed. So as you find issues with it, you improve it, and you go back over here, you research, you imagine, you replan it, you recreate it, you retest it, you re-improve it, and you keep doing that until you get a solution that you like to share with somebody. That's just a general overview of an engineering design process, okay? All right, this is your next classwork. This should take about 5 minutes as well as the last one. So put this in the same section as the classwork you just did. You're going to have to upload this to Google Classroom eventually too. So the classwork is, think about your science class last year. Most of you took chemistry. If you didn't, just think about whatever science class you took last year. Pick one of the NGSS practices that you think you used well last year. So the NGSS practices are right here in the right side for you to look at. So think about one of these that you used last year in chemistry and answer the question, how did you use this practice in class? So pick one of these that you maybe used well in class last year, and then in order to receive full credit, you need to answer all of these parts to the question. What was the topic? What were you learning about in chemistry? What was the assignment or task that you were doing in chemistry? and how does this relate to the NGSS practice? So pick one of these practices that you think you did well last year. Think about a specific instance in chemistry that you used that practice, and talk about how you used it, okay? You need 3 full sentences, and it's optional. I love drawings from students if they are appropriate and on task. So please feel free to add an appropriate and related drawing to answer this question. So please pause the video and spend about 5 to 10 minutes on this question, and then you can play the video again. All right, and that is the end of the lecture for today. I'm going to do a quick exit ticket, so I know I just made you do something, but this is your exit ticket, which means this counts as a different little write-up that you're going to turn in, and it counts for participation points for this class. So please answer the following question in 4 to 5 sentences so that I learn a little bit more about your science background last year. So what were some things that you enjoyed about science class last year? You can include the topics you learned, the different activities you did, etc. Feel free to add a related and appropriate drawing, just like the last question. So please pause the video, write a little exit ticket. This can go in your classwork section as well. So it's just like basically another classwork question. You can add a drawing if you want to, and then I'll ask you to upload that. So pause the video and then play it for your final overview of what your homework is going to be. All right, just a quick overview for your homework. Please submit the 2 classworks I made you do during this video. You need to have them written in your handwriting and uploaded to Google Classroom. And then please submit the exit ticket. That also needs to be written work in your handwriting, and that needs to be submitted to Google Classroom. So please title that exit ticket and then put it on there. And then I also have put a student survey on Google Classroom. It's very easy. It's just you talking about yourself. And this one can be typed and then upload that to Google Classroom, okay? So when you click on it, it should automatically make a copy for you, and then you can submit that when you're done with it. Okay, this whole thing should not take you very long. So go ahead and do those things, and I will see you when you come into class.